Let me carry on the previous conversation. This is a device which generates AC current by using mechanical energy. The design, in this design, we have only one coil in the stator and two coils in the stator in the opposite direction, act as a pair of coils. The difference I told you during the rotation, either this device or this device, same output we expect, but quality of the output, quality of the cycle of AC, output AC is improved a lot by from this design to this design. That is what I told you in the last class. Now let us increase the number of coils in the stator further, the same device like this. Let us increase the number of coils in the stator. Let us increase the number to 3 and the arrangement in symmetric like this at a difference of 120 degree. That is how these coils, 3 coils, and do the mechanical rotation of this same magnet, 2 poles. What we get in this mechanical action, look at that, each coil act as what is produces a current, that is one phase of current, one more phase of current, another phase of current. Power are generated in 3 different conductors. But here the power is generated in only one conductor, one phase. In this design, with this number of coils, the power is generated in 3 different conductors. That is, windings are there, one end, and one end, other end, the other end, other end. So one end produces a power, one phase. That is, one phase, one more phase from this coil, another phase from this coil. From 3 different coils we get 3 AC powers are generated. They are called as phase 1, phase 2, phase 3. On the other end of the coil is a neutral, this is a neutral, this is a neutral. All the 3 neutrals can be combined to form one neutral. You can combine to get only one neutral. In this generation, you see the difference. AC power is generated in 3 different conductors. Almost same energy. The AC power, same power of AC is generated in 3 different conductors. There also only one conductor. Look at the difference between this design and this design. Difference here, the output, the efficiency of the output, that is output energy in the form of AC, it is almost triple this output in 3 different conductors. And the neutral like this, one neutral. By increasing the number of coils, this is the advantage, more power output, more efficiency in the output of AC we get. In the next design, let us double these coils, 3 into 4, exactly like 2 opposite behave like a pair of coils like this. increase the number of coils to 6 number of coils in the stator, the rotor will remain same, magnetic rotor. Let us see what will happen. And upon rotation, here also generates same phase of current, 3 phases and 1 neutral like this. The connections are, look at the connections. Here between the pair like the similar connections. One end will come out as one phase. Other end of the same coil will take it to the next coil and winding over and come out as a neutral. Similar to this. And the same thing you can apply between these two coils in the opposite direction. One end will go as a phase and other end will be drawn, taking to this coil and giving windings and come out as a neutral. Similarly, we have this coil, one end will come out as a phase, other end is taken out to this coil and giving windings and come out. See again, these neutrals are combined to give only one neutral conductor. Here 3 phases we get, here also 3 phases we get. What difference you are finding between these and these? It becomes more efficient. More efficient means by increasing the number of coils like this, efficiency is increased as well as quality of the AC output, AC signal. Here 3 signals are obtained. 3 signals are obtained. So one signal from one signal AC signal from this phase, another AC from this phase, and another AC signal from this phase. Similarly, we have this. These signals are represented like this. The signal from this is one way. Continue with every rotation. And signal in this wave. And signal from this phase. Look at that. We have signals are generated. And these signals are generated in 3 different conductors but from the same device. Therefore, they are represented in only one line. 3 signals, that is 3 cycles, we are producing at a difference. What is that? At a phase difference of 120 degree. The total phase angle for every cycle is 360 degree. But these are produced simultaneously with a phase difference of 120 degree each between this and this phase difference. These cycles are continuously generated for every rotation. And because of this fashion of arrangement, symmetric fashion and 6 coils, the output, that is output wave, output AC cycle, the quality is improved, smooth output, no fluctuation in voltage. Efficiency, what is that? Efficiency is increased and quality of output cycle also improved by increasing the number of slots or coils in this stator like this. So this is how we can increase the efficiency as well as the quality of the AC cycle by improving the design of the device. But we cannot increase as many coils as we expect. The reason, it has a limitation. You can increase, but it has a limitation. Limitation is related to space. The space constraint. Very important, space is there now. There is a space constraint and also heat dissipation. because in this generation heat is dissipated due to that magnetic interaction and conductor. Heat, some of the energy will go as a waste as in the form of heat. Because of dissipation of heat and the space constraint, we cannot increase the number of slots. Only to certain limit is there. We should not go beyond that limit. So this is what the ideal one for this. This is called 6 slots, 2 poles. 6 slots, 2 poles. And what is the other possible designing? The same design with the same number of slots. Same number of slots. No difference. Here was the difference here. We are increasing the number of magnetic poles. Here it is 2, now it has become 4. Always increase the magnetic poles in pairs. 2 to 4, 4 to 6 like that. And magnetic poles should have in this fashion, always in a alternate fashion, north, south, south, north, north, like this we have to increase the magnetic poles. In this cylinder, what is that rotating cylinder, the magnetic poles are fixed like this. 4 poles are fixed. If you allow to rotate this rotator, this also generates electric power. Of course, more output and quality of AC, and by increasing the number of poles, what you get? The frequency of the output increases. The frequency of the output increases. That is the purpose of increasing this. Here also, we cannot increase as many poles as we expect. There is a limitation. I told you the limitation like this. Spatial constraint and heat dissipation and many other problems. That is complexity in making the device. And one more important point, for any kind of design like this formula is applicable. This is important formula in electrical engineering. What is the formula is known as N into P equals 120F. What N stands for? The speed of the rotor, that is the speed of the rotating magnet. The speed always measured in minutes as RPM, rotation per minute, rotation per minute, RPM. That is N unit of speed of the rotor, and P stands for number of poles in the rotor. Here number of poles is 2, here 4 number of poles, and F stands for the frequency of the AC cycle, output AC cycle frequency. Look at this equation directly. The frequency of the AC output increases if the number of poles increases. Look at that. Keeping the speed remains constant, or keeping the number of poles constant, the frequency of the AC output can also increase by increasing the speed of the rotator. There is advantage. This equation is applicable for that. Any kind of this generator or motors. So this is known as frequency. Usually at the production level, that is generation, in most of the cases the frequency of the AC generator is almost will be at 50 hertz or 60 hertz. That is 50 cycles per second, 60 cycles per second. In that way it is designed. This is about the construction and designing of the AC generator. This is about the output of of the AC. And one more point I need to stress upon here, in the generation of AC current at large scale, at large scale, I said there are two options. A rotor may be a conductor, a rotor may be a magnet. We go for the option, what is the option is that always for this rotor, a magnetic rotor, not a conductor is a rotor. The reason, very important reason, look at that. This magnetic rotator is lighter compared to this conductor. Usually the conductors carries what is the number of windings load. So many so many coils. Here I mentioned only one coil. You can have three more, that is two more coils fixed, what is that? At an angle of 120 degree, that is one coil is there. So along this axis, we can fix the coils, two more coils, 23 coils at an angle of 120 degree. So they have separate slips and rings like this, produces three-phase current also here. But here due to heavy load, weight, that is on comparison with weight, what is that? Light weight, heavy weight. Carries what is that? Weight of copper windings. Lighter the rotator, easier for rotation, and can attain what is that? Maximum, what is that? Rotational speed with this. Heavier the rotor, difficult to rotate, requires more energy for rotation. And if the weight is weight is more, for this rotation produces more and more wear and tear, maintenance problem. Maintenance is difficult, but we don't expect that amount of wear and tear. Maintenance is somehow beneficial here. Economic, yes. So these are the advantages of using this magnet as a rotor in the generation of AC at large scale. Maintenance, cost of maintenance, and duration also important. The duration, lighter the rotator, longer the duration. Maintenance is also easy. That is why we go for this kind of rotator in the AC generation. And in this design, why it produces more amount of voltage, more amount of power is generated, and quality of power. Look at here, there are number of coils are there. With this coil, during the rotation, here symmetric arrangement is there. Magnetic field is uniformly distributed. Not only that, during the rotation, magnetic field is sweeping through the coil, through the conductor. It is maximum sweeping of magnetic flux through the conductor. That is possible. Maximum sweeping of magnetic flux through the conductor is possible. With symmetry, you get the quality of this and more power output. If the flux sweep through the conductor, if it is maximized or becomes more power output. That is why we have this design. So design and the purpose, it is all explained in detail about the AC generator. Once the AC is generated, usually in the form of three phases from the generator at the grid, three phases like this. So once it is generated, it requires voltage step up for a transmission over a long distance to avoid the loss of power. There is always a loss of power. To avoid that loss of power, minimize the loss of power, you have to step up the voltage, very high voltage, and we step down the voltage where the distribution at the distribution point at the location where the power is distributed, maybe a residential area or commercial area or what is that industrial area. Usually we see that the power distribution lines, what is that overhead lines, will carry what is that, there are four conductors. Among them, three conductors are phases. Phase 1 like this now. Phase 1, phase 2, phase 2. That is the power carrying. And other one is a neutral like this. Four lines. Usually you have seen that in any locality where the power requires to be distributed, we constructed the power lines with four conductors. Three of them are phases and the other is neutral like this. And in the distribution of power, you will follow this procedure. Suppose in a road, if there are 15 houses, you have to give the connection like this. There are three phases. One phase is connected to 5 houses. Another phase connected to 5 more houses. And another phase connected to 5 more houses in that road for equal distribution of power. Otherwise, if you give to the same phase, it overloads. To avoid the overloading, for equal distribution of power in a road, we follow this procedure. Usually, you have observed that the electric company will give connections like this. This is how we follow the power distribution. So this is a generation of electricity and power distribution at the area where we need to be distributed. These are the details about the AC. With this, we have completed this. Thank you very much.